Hello. In this tutorial I will explain to you the hardware layer. Basically the information that I'm going to give you will be important so you can understand what happened when a user opens your application. So the example that I'll give you is when a client opens some URL in the browser, what happened to that request, to which hardware that request it will pass. So basically that's what I will explain to you. So let's start. So let's say that you have a web application that runs in the browser. The browser wants to see that specific application. So the browser will write a specific URL in this address bar and it will press enter. What happens then? So that's the purpose of this tutorial, to explain to you all the surroundings that are involved. Okay, so browser sends the URL and that URL will pass then for a firewall, for the firewall for your computer. If this passes, then it will send this to the Wi-Fi or the Ethernet card or adapter. Then let me put here some spaces. Then the Ethernet or card adapter, it will send the request to the network where your computer it is connected. So let's put here connected network. So then that request will be forwarded to your router. So until here, so until all this process here, you have a private internal IP. Then the router will send the request to your modem, where in here you still have the specific private internal IP. Meanwhile, in here you may have other routers, whatever, if it applies or not. So if you get until here, basically that's what we called. In here you have a NAT. It's like an internal network. If you have a router connected to another router, then you have another NAT inside in here. Something like that. So basically imagine this as you can have like specific ranges of IPs inside of each router. And so let's say that this router here, so the IP that you have here in this router, let's say that you do have 128.0.100. This will be your IP. This router IP will be something like this, but in this network here, it could be a different network. So in here maybe let's say that, or you have the same standard IPs, or you can have a different one. So if you have the same standard, it means that the ranges of these, it means that maybe the IP here will be between let's say between 50 to 100 or to 105, whatever. And then in here you have another network which could be between 106 to 200, something like that, where the IP here it could be something like this, your IP. Well, in this case will not be your IP, but will be the IP of this router inside of this network here. So these just examples. Or you could have a completely different network, something like this. And then this request will be forwarded to the modem, and then the modem it will send your request to the web. What happened then? Before the web, then it will send the request to your ISP. So what is the ISP? The ISP is the internet provider. So it's basically when you have the modem, you have an internet service that you pay every month. So that service, all the requests, so the modem all the requests that arrives to the modem, it will send to the web, but through the ISP servers. So all the requests pass through your ISP. That's why the ISP can see everything that you browse. They know that information, unless you have a VPN. Okay, so from the point that the request get out from the modem, then what happens is that from here you start having a public IP. So from this point, that's where you have a public IP from the modem part. Okay. So basically this is a very explanation what happens when the request gets out from your computer. But then the request it will send to the web, and then in the web will send to the correct specific server. So how does the web knows this? So this is done through the IP. But although the client didn't wrote IP in the browser, the client wrote some domain. So something like this in the browser. So how does the web knows what is the IP that it should forward? So basically the process that happens is that the browser sends first the request to the specific DNS. The DNS is the domain name servers, to get the correspondent IP of the URL of the domain that was routed in the browser, and the DNS then it returns with the correspondent IP, saying that this IP is something like whatever. I'm just writing some random numbers, whatever, and so it will return the correspondent IP. So then the browser can send then a new request to all these layers here. Okay, so next, then the browser, when it gets the IP, makes the correspondent request to the server, to the destination server, and then the destination server returns the response. If this is in the browser, if it is a HTML app, it will return the correspondent HTML, so then the browser can show you the correct page. So that's basically what happened in a generic overview. Okay. So then what happens when this request arrives to the specific server? Well, before the request arrives to the specific server, when the browser sends this to the web is basically a network of routers, and that routers will send that specific request until it arrives to the destination server. So the routers, they have their own algorithms to know and to forward the correspondent IPs to the right path. So when the request arrives to the server, so first of all the servers needs to be able to receive that specific request. So let's say that the URL that the client wrote in the browser was something like this, ABC, whatever. So by default this means that we have here the port 80. So if this protocol, if it will be HTTP, the default the port it is 80. If the protocol it is HTTPS, the default port it is 443. So if we want some specific port, the user needs to write this in the domain with a specific port, like something like that. So otherwise the browser doesn't know. What I'm saying is that you don't need to write the port number only if it are standard ports. HTTPS is 443, for HTTP is port 80. Otherwise you need always to write the correspondent port name in the URL. Okay, so then these requests arrives to the specific server. And then what happened then? So basically the server, it will receive this request to his Ethernet or Wi-Fi card, and then we'll pass that request to the firewall, and we'll check if it passes through the firewall. So it will check basically if this port it is open. So we need to have this port open, and we need to have a service running on this port. And then that service could be a web server that it receives requests, so it receives the specific URL and then redirects that specific URL to the specific application. Let's say that in your web server, it could be, if it is a web server, it could be Apache, and Apache can have multiple applications running there. the application A, the application B, the application C, and automatically Apache is configured, the web server is configured to read the specific domain or parts of the URL, and then to redirect to the right folder where it's running your application. Where is your application code or application build? Basically that's the process that happens. Then the applications, the code, it will parse the specific request, it will it will return a specific output, a response, and automatically all this flow, it is backwards. So the application returns this to the web server, web service returns this to the web through the specific port, the firewall, the Ethernet, Wi-Fi, the same thing here, then to the specific router, well, in this case to the specific connected network, then to the router, to the modem, to the ISP, that where the server it is connected, and then returns this to the web. And then the web, it's here and do all this backward process where this ISP to receive that request, it will send this request to the specific modem, the router, insights, and all of this until it gets to the client browser, where the client browser, it will receive the output, the response, which will be, in this case, if it is a web app, in this case it could be a HTML, and then you parse the HTML and it will show the HTML to the client in a user-friendly way. So basically this is the flow that happens. Okay, so additionally, what happens inside of the web and why this is important, I explaining to you extra information, which is between the let's put it, connections between continents. And why is this important? This is important because depending of the software that you are creating, you need to be very careful and you need to pay attention to these small details because of the latency and the bandwidth. And because of the cache system. So this is important when you are setting and planning your distributed system in the clouds. You need to know if you want to put this in some CDN, if you want to create in some caches, where that cache it will be in which geolocation it will be. So you need to be concerned about all of this, if it is worth it, if it is not, because this automatically then you need to support the costs to having all this infrastructure. So what I will explain to you is exactly so you can have all the information to make the correct decision. So how is the connection between countries done? So you can have two ways. The connection between the countries are done based through cable or through the satellites. So if it is through cable between continents, we have underwater cables that connects all the continents, and then inside of each continent we have the correspondent cables that connect also the specific countries. But the connections are done not only through cables but also done through satellites. So we have one starlight, if I'm not mistaken it is the Starlight, which is from the Tesla guy, which one where you can hire a specifically monthly service to have your own internet through satellites, and all the connections, instead of being done through the cable, it will be done through the satellites. So, and this you have latency. So the ping latency for the satellites is around 50 milliseconds, and the latency between the cables between two countries, between like US and Europe, we are talking about between 100 milliseconds to 150 milliseconds, if I'm not mistaken. This is the ping latency that we have. Then additionally we have problems of bandwidth. So through cable you have a bigger bandwidth, in satellites you have smaller bandwidth. So why this is important? So let me give an example. So let's say that you want to create a streaming app, a video streaming app with 4K quality, something like that. If you want to do this, and if you want to host your servers in Europe, and your targets are US based people, then you'll have problems. You'll have problems. You have problems. Why? Because the companies that rent these cables, basically the way that it works is, so the continents are connected through cables. These cables belong to a specific company. This company, so it will connect the cables through two endpoints. So let's say that it will connect the specific cable. So let's put it here. Cables. It will connect between US to Europe. It will connect. It will have a cables between these two continents, where the cable in here it will located in New York, and the cable in here it will be located in UK, something like that. So the infrastructure, that data center, that physical data center, it is managed by a company in New York and in UK. Then the ISPs in the specific countries, it will rent a specific bandwidths and speeds. Sorry, I'm misspelling all of this. Okay, it will rent a specific bandwidths and speeds to these companies. Let me give an example. So you can have one of these companies. It is, if I'm not mistaken, Akamai, and we have an ISP which could be Verizon, if I'm not mistaken, or AT&T, something like that, whatever. So AT&T and Verizon, basically, it will rent a huge, and you will pay millions and millions of dollars every month to Akamai, so they can use the pipeline to Europe. The same thing happened in Europe, in UK. The correspondence ISPs in UK to rent to Akamai the specific bandwidths, also and speeds, to have the connections to US. So basically, these like the ISPs rent this type of service to these infrastructure companies that have these specific services. If you want to create an app and streaming that over the cables, basically you will be, if you have a lot of clients, you will occupy a lot of bandwidth of your ISP, and basically your ISP, it will decrease the latency, or it will, in this case, it will decrease the speed and increase the latency of your bandwidth. So you can have a very bad quality in your service. So basically they can even cut completely the services of streaming that you are currently having, because then this will because they don't have enough budget, because the money that you are renting, the service that you are paying to the ISP is not enough for the cost that you are having to the correspondent infrastructure. So that's why it's important you understand this, because in the case, the correct way to having this is that you needed to have a CDN. If your videos, if the streaming it is hosted in Europe, then you needed to have caching systems in US to only pass the videos once, and after the videos will pass once, so you will download, let's put it here, download, upload, whatever, the videos once, and then the streaming, it will be based, it will get out the streaming, it will get out from the US servers to multiple clients. So like this, the bandwidth, it will be internal. So then it will be only the cables, only the infrastructure will be only for the Verizon or AT&T infrastructure. So you will not have that problems anymore. So that's why you need to be careful when you are streaming and passing huge amount of information across continents. That's one of the examples. That's why this information it is important. That's why it's important you understand how all this flow works, it's very important. So then you can understand the latency between, this is the latency between all these infrastructures. So then you can decide if you want to use cache or if you want to use specific type of technologies that can make that latency smaller, like caching, and make your app to be faster, to have a better speed. So basically that's it. So the idea of this tutorial is to explain to you how the hardware works. Every time that the client makes a request to the browser, what happened behind it, and then from the server sides, what happened also. So this is also important, so you can understand that there is some service running in some port in the server side. So if you want to create, so let's say that you want to serve a specific application that doesn't work, that doesn't run inside of a web server, you can create your own app with your own specific code, creating sockets in the TCP layer that will be listening in a specific port. Why this is important? So let's say that you can have the app A talking with the app B and the app B talking with the app C, but doing all of this internally, because all the app C will have a port open, a specific port open, the app B will have a specific other port open, and the app A can have other specific port open. They don't need to be accessible only through the web servers. You can open ports, and then don't forget, if you put some service running on a specific port, you need to open that specific port and configure it. You need to configure it in the firewall, that specific port, otherwise any request that you do it will be blocked. So pay attention that the firewall is able not only to block the public requests, the external requests to a specific port, but is also able to block internal requests also. And that's it. So thank you very much.